This is video number 1 for sections 9.5 and 9.6, solving square root equations. In this lesson, we're going to talk about solving equations that have a radical symbol right in it. You can see our first example here has a square root in the equation. This 5 is a coefficient, not an index. This is 5 times the square root of x plus 4. Over on the side, I've given you a list of steps to follow for solving equations that have square roots. Let's go ahead and follow those steps. Step 1 says, get that radical by itself. So anything else that's outside the radical is considered junk. It's in our way. We really need to get rid of it. In this particular problem, that would mean the 5 and the 2. Of course, we always deal with our moving terms around first, so I'll need to begin by subtracting 2 from both sides. Notice you really need to pay attention to where the radical symbol ends, right? The x plus 4 is the stuff that's inside it. The 2 was outside. All right, and then continuing to get rid of the junk, the other piece of junk would be the 5. It's being multiplied, so I will divide both sides by 5 in order to rid myself of it. And so that's the end of step 1. You'll notice it says over here, it would have been okay to leave that 5 in the front. We'll talk about that a little bit later. If I can get rid of it easily, though, which I could here by just dividing, it created a nice simple number, then I generally go ahead and do that. Okay, well, the radical is now by itself, and of course, you know, you're probably eyeing that 4 and knowing that you're going to need to move that around at some point. The problem, though, is right now it's trapped inside that radical along with the x. Until we rid ourselves of the radical, we can't touch this stuff on the inside. And so I have to ask myself, well, how do you get rid of a square root? What's the inverse of square rooting something? And the answer is squaring something. The next step, the key step in the process, is you square each side. Notice the word side is underlined. I'm doing that for emphasis. It's not that you're squaring pieces, you're squaring the entire left side, and you're squaring the entire right side. And I would really recommend you write it just as I did, with a big giant parentheses and a squared. What happens next? Well, squaring a square root simply wipes out the square root, right? When you multiply a square root by itself, all you're left with is what was inside. So that's very simple. On the right, 7 squared is 49. And just like that, we've rid ourselves of that radical. All right, step 3 is do your algebra to finish off isolating the x, solve the resulting equation. Obviously, in this case, that's very easy. Just subtract 4. And I end up with x equals 45. And I would love to put a box around that and move on, but I can't because of step 4 over here. Step 4 says you must check the answer in the original equation to see if it's valid. We had a similar issue come up in chapter 8. Because of the whole bad x situation, right? We had to make sure that our x wasn't a bad x. It's even worse here in chapter 9. These square root equations are just notorious for extraneous solutions that are fake, that don't work. And unfortunately, the only way to know here is to do a full check. It's not even a partial check like we did in chapter 8. You have to go off on the side and do a full check. In fact, your work will be incomplete unless you are showing that check. You got to go back to the original equation, copy it down, replace those x's with your candidate, 45, and then work out the math on each side and see if it comes out to be true. So I add the numbers inside the square root. 49 is a perfect square, so the square root of 49 is 7. Remember, there's a times in between there. 5 times 7 is 35, plus 2 is 37. That's what I was hoping to get on the other side, and so it worked. Only when you do a full check can you go back over here and say, okay, my candidate turned out to be an actual solution. Let's move on now to part B and try another example here. Similar situation, I've got another square root equation. That 3 there is a coefficient. Let's follow that same list of steps. The first step was isolate the radical, so get that radical by itself. This 3 and this 4, those are my junk this time. So I'll start by subtracting 4 from both sides. And then the other piece of junk is the 3. And I could do the same thing I did last time. I could divide both sides by 3. I just noticed that that creates kind of a yucky fraction over here on the right, and I'd probably end up just having to clear the fraction later anyway. So if that's going to happen, it is okay to leave the coefficient here and proceed to the next step. Let me show you. The next step is the big step, right, where we square both sides. Again, both sides being so important. It's this entire side getting squared and this entire side getting squared. Those parentheses are important. On the left, this is a times in here, right? And one of our rules of exponents said that you can distribute an exponent to a multiplication problem. So I can go ahead and do that. On the left, I can distribute that squared to the 3. 3 squared is 9. And then I can distribute the squared to the square root. When I square a square root, it just makes the square root disappear. On the right side, I have -2 times -2, which is +4. So we've squared both sides, and the radical is gone. All right, step 3, solve the resulting equation. Now that that radical is gone, I can touch all this stuff over here. Looks like I need to distribute as my next step, and then move the 36 over. And then we need to divide both sides by -9. It looks like I don't end up with a great answer this time. 9 does not go into 32 evenly. In fact, there's not even any common factors. I can at least cancel out the negative signs. But it looks like this time I get this fraction x equals 32/9. Now again, remember, this is just a candidate answer at this point. I don't know yet if this is the right answer or not until I do a full check. Since the fraction is kind of yucky to deal with, I would suggest going to the calculator and figuring out the decimal version of it. I got about 3.56, and then I need to take that value, go back to my original equation, and run a full check. Again, that's a required part of the work. I really don't know if my answer is correct until I run that check. So let's copy the equation down, filling in that 3.56 number. And then there's not really any reason to work this out by hand. I would just type that left side into the calculator and write down what I end up with. Be careful when you type it in. Only the 4 minus 3.56 belongs in the square root, right? This +4 is separate. Also keep in mind, we did round our answer off, so we shouldn't expect that these two sides will match exactly, but they ought to be pretty close. Well, what I got from the calculator is 5.99. That is not very close. Maybe if I had gotten 1.99, I would have said yes, I think it worked. But clearly, this is not true. It is not true when you plug in 3.56 that you get a true statement. What does that mean? It means my candidate answer down here was an extraneous solution. It's no good. I have to throw it out. It was the only candidate I had, which means my final answer to this problem is no solution. Sometimes you can see this no solution thing coming, not always, but there are times where you can predict this is going to happen. For us, I saw this coming right at this stage here, before we even squared both sides. In fact, let me rewrite that without the squaring. Take a look at this. This says I'm looking for an x to fill in right here, and when I take the square root of that subtraction problem and multiply it by 3, I'm supposed to come up with -2. Well, that's impossible. When you take the square root of a number, I don't care what the number is, it always comes out to be positive. right? And or 0, but never negative. It has to be a positive number or 0. Well, if you take a positive or 0 and multiply it by 3, you're certainly not going to end up with -2. This is an impossible equation, which is why we're saying no solution. Now, you can't always see that ahead of time, but there are times where you can. In any case, make sure you are running a full check so that you know whether you should be keeping your answer or throwing it out and saying no solution.